All right, ladies and gentlemen, we're going to go ahead and get started talking about physical and chemical changes in properties. Now, you just finished taking a look at some different objects that were given out at your tables, and you made some observations of those particular objects. And as you were making those observations, hopefully you observed things like the shape of the object or the color of the object, perhaps what the object was made out of. Maybe you observed whether or not the object had a particular odor. Hopefully you did not take the opportunity to observe whether or not the object had a particular taste, because of course we know that that would be against lab safety rules. But hopefully you took a look. Maybe you even noticed whether or not it made a sound as you dropped it gently on the table or tapped it in some way. All of these are observations. We talked about observations back in sixth grade, and I've referred to them on and off since then. Observations, of course, are when you take in information using your senses. So in our exploration over the next several days of physical and chemical properties and physical and chemical changes, we're going to start out by taking a look at the physical properties and changes today, and then later on move into chemical. So physical properties are those things that you can detect with your senses. So they're observations. Some of the most obvious ones are things like color and shape. Now you have a box there on your notes, and you can start filling in the list of some of these physical properties, starting with color and shape. Doesn't matter if you go across the box or down each column. It doesn't make a difference as long as you list the different properties that we're about to talk about. So with your senses, you can determine color, you can determine shape. You can also determine things like texture. Is it bumpy? Is it smooth? You can detect odor, taste when appropriate, of course, sounds. All of these are physical properties. Some other physical properties include, and you're continuing to put these in the box, include volume, mass, density. Now, you can't just look at something and see its volume, mass, or density, but you can use tools to take measurements and then do calculations, and you can observe those measurements and calculations. The melting point of an object, the boiling point of a substance. These are also physical properties. Again, you can't just look at something and be able to tell what its melting point or its boiling point is. But again, we have tools to be able to figure that out. And also state of matter. And of course, the three major states of matter would be solid, liquid, gas, and there's also plasma. So what state of matter a particular material is in, or a particular substance is in, is a physical property. So each of the substances that you were given today were solids. That would be a physical property of that substance. Maybe some of you wrote that down. Okay, so each of these things is a physical property. So at this point, you should have filled your box on your notes page there with the different types of physical properties. Well, we can also talk about something called physical changes. So certain types of changes that we can make to a substance are considered to be physical changes. Some examples, melting. So if it melts, or evaporates, or it boils. So these are going on the lines. And number 3, it doesn't matter what order you put them in. I know the lines are different sizes. That doesn't really matter. Also, if something freezes, if it breaks, if it dissolves, anything that is done to a substance or happens to a substance that does not actually change the identity of the substance, that is considered to be a physical change. Okay? If I were to take a piece of paper and tear it in half, I would have just done a physical change to that piece of paper. It did not change it from paper to some other substance. It is still paper. No matter how many times I tear that piece of paper up, it is still going to be a piece of paper. I have simply made a physical change to that paper. All right, so let's say for just a moment that we had a slice of bread, or a loaf of bread, and we were to take and slice off a piece of bread from that loaf. We would not have made a change that actually changed that bread to some other substance. You still have bread. It looks a little bit different, so we have altered the appearance of that bread, but there hasn't been any permanent change made. No kind of change that actually changed it from bread to some other substance. And so because of that, cutting a slice of bread off from a loaf of bread is an example of a physical change. So if you take sugar and you put it into a glass of boiling water and you dissolve that sugar, stir it up, let it dissolve, that is a physical change. There's been no permanent change either way. We can actually recover the sugar. We can get the sugar back again. All right. We can set the container out. We could go ahead and just let it sit there for a long time, let the water evaporate, and we would be left with sugar residue in the container when it's all said and done. So you can actually get the sugar back, even though it appears that the sugar basically like disappears. It hasn't. It has broken down into very, very small substances. But remember, when something breaks, or down into very small pieces. But when something breaks, it's a physical change. We haven't changed the substance at all. And so we could even come up with a way, and this is what you want to fill into number 7, this section down at the bottom. We could actually come up with a way of saving both the water and the sugar. So we could set up a system where we actually, it would be what we call a closed system. So all the containers would be attached to each other and sealed. But we could actually boil the water. The steam could then travel through a tube from one container to the other, where the water could condense again into water. So you end up with a container that has water in it. And then the original container would still have the sugar in it. So we could actually manage to recover both the water and the sugar. So there was no permanent change done there. Sometimes with a physical change, it's very difficult, nearly impossible. And to say that there's never a permanent change with a physical change is probably not, chemically speaking, entirely true. But for our purposes and what we're going to be dealing with here in physical science, it is nearly true. So sometimes those changes are very difficult to say that we could undo them, so to speak, and we can't always exactly undo them, but we haven't actually changed the substance to another substance. We still have sugar, we still have water. It's not a new substance that we have there. All right, so when you have a situation where you actually could, by physical means, and sometimes it's not simple, like I said, but when you can, by physical means, such as boiling, separate the substances back out again, then you are dealing with something called a mixture. When we get to talking about chemical changes, we'll hear the term compound and things like that. When we're talking about compounds, we're talking about things that have chemically bonded together. However, when we're talking about a mixture, we're talking about something where the individual components have not chemically bonded to each other. And because they're not chemically bonded, there has been no change in the actual substance, or at least no change in what the actual substance is or substance is. So let's talk just a moment about some different possible mixtures. We're actually we've skipped number 8 temporarily on your paper. Hopefully you noticed that. Number 9, I'm going to go back a little bit. Number 9 was talking about the individual components. We're going to come back to number 8 tomorrow, actually, but we're not going to talk about that one right now. So let's take a look at some other possibilities. Let's say you had some iron filings, so really tiny little shavings of iron, and you had some sand, and you took those two things and you mixed them together. How could we possibly separate that particular mixture using what we know about their physical properties? Well, we could study the physical properties of both sand and iron and come up with a strategy. So, what are some of the physical properties of sand? Well, we know it's small and granular. We know it doesn't really dissolve in water the way that sugar does. We know that it would sink to the bottom in water eventually if it were like shook up. How about iron? Well, we know that iron is a metal. We know that it's also kind of heavy. It would probably sink in water. We also know that iron is magnetic. So, since iron is magnetic, it has the property of magnetism, we could actually take a magnet and kind of pass it over the sand and iron filings, maybe even get that magnet down into the sand and iron filings mixture. And of course, because sand is not magnetic and iron is, only the iron filings would actually stick to the magnet. The sand would get left behind. And now we have managed to separate the sand and the iron filings. All right. So take just a moment to kind of write that down for number 10 on how you would separate a mixture of sand and iron. You don't need to write it down word for word as it is here, but make sure you get the idea that using a magnet to attract the iron filings, because they are magnetic and the sand is not, would help you to be able to separate the sand and the iron. All right, how about sugar and sand? How could you separate those? Think about it for just a second. What do you know about sand and sugar that would help you to be able to separate those? Neither one of them is magnetic. They're both about the same size, about the same texture, so those are probably not physical properties that are going to help us in the separating of these two substances. However, we know that sugar dissolves in water and sand does not. Well, if we were to add that sand and sugar mixture to some water, or add some water to it, stir it around, the sugar is going to dissolve. The sand is not going to dissolve. Well, perhaps then we could take that new mixture of now 3 substances, sand, sugar, water. Maybe we could filter that, pour it through a filter. The sand will perhaps be trapped then by the filter as the sugar water gets through the filter and is trapped in a container beneath. Then, as we talked about before, you can heat the sugar water. The water evaporates, leaving the sugar behind, or if you don't want to take the chance of burning your sugar, you can just allow it to evaporate in the open air. And now you've separated so that you have your sand left over in the filter, you have your sugar left over in the container. You could even take the filtered sand and spread it out on newspaper or something and allow the water to evaporate from that as well, the little bit of water that's left. Would you have separated it completely? Well, this process is probably not quite detailed enough to be able to completely separate the sand and the sugar, but you would have separated most of it. And again, we used physical properties to be able to separate those. One physical property we haven't talked about yet is the idea of viscosity. And viscosity is the resistance to flow. The resistance to flow. We talked about viscosity, actually, for those of you who were here in 6th grade. We talked about viscosity when we talked about volcanoes. And we talked about the fact that different kinds of volcanoes have different viscosities of magma. Some of the magma is very liquidy, flows very quickly, whereas other magma flows much more slowly. So a liquid that is considered to be a viscous liquid does not flow easily. So, for example, molasses and maybe a lot of shampoos, or maybe even better example would be hair conditioner, would be examples of very viscous liquids. Okay, maybe you can think of other viscous liquids that don't flow very easily. Elmer's glue would probably be considered a pretty viscous liquid also. All right. Water, on the other hand, is not very viscous. It flows very easily. It is not difficult to pour it out of a small container. So how could we test substances to be able to compare their viscosities? Well, we can test viscosity a couple of different ways. We can either drop something into a substance to see how quickly it will fall through the liquid. You could use a marble or maybe a small pearl or a bead. Drop it into the substance and then time it to see how quickly it falls down to the bottom of that substance. You could also, and we did this a little bit in 6th grade, you could put a small amount of the substance on a board, on a slick board. And then you tilt that board and you time how long it takes that substance to flow to the bottom of the board. So you could test the viscosity of different substances. We could even help determine what a substance is based on its viscosity. If we have an unknown clear substance, but it has a very thick, very viscous. It's a very viscous liquid. Then we might guess that perhaps it's more likely to be, say, corn syrup than it is to be water, because water would be much less viscous. We could drop something into that clear substance to see how quickly it falls to the bottom. If it falls all the way to the bottom very quickly, perhaps it's liquid or some other clear substance that has clear liquid that has a low viscosity. So one other physical property that we did mention but haven't talked a lot about yet is density. We had that in our list previously, but didn't really talk about it too much. Density, you might remember, has to do with kind of how much stuff or how much matter is there in a given amount of space. You can't actually see density, not really. Technically, it needs to be calculated, and we can do that as long as we are able to calculate the mass and the volume of a substance. So density is calculated by doing mass divided by volume. So on your paper there you have a little slash. That is, of course, supposed to be a division symbol. So it is mass divided by volume, and that will give you density. And so you can have a couple of substances that look very similar to each other that may actually in real life have different densities. You can use density to be able to determine what kind of substance you are dealing with when you have kind of a mystery substance, so to speak, or just when you are listing the physical properties of a particular substance. One of the properties that you can list is density. All right, so ladies and gents, you have no homework tonight. Well, actually, I take that back. You actually do have some homework that you will be told about in just a few minutes. It is simply watching a video, and so you'll be told about that in a couple of minutes. And you do want to make sure you do that in order to be prepared for the lab that we will be doing tomorrow. All right, ladies and gentlemen, have a good day, and we will start getting into more about chemical properties and changes later in the week. Have a great day. Thanks, guys.